Öppen så jag kan se in i dina ögon. Vår blick du är i månskinn.
My name is Anders. I come from Hegel Music System in Norway. We will talk about technology in general and how we use technology to improve our sound. Hegel started in 1988, so we've been around for almost 24 years. And Hegel was founded by a guy called Bent Holter. He was playing in a rock band called Hegel Band. That's where the name comes from.
Was there a meaning in Norway?
No, the rock band in turn was named after the German philosopher. But we were named after the rock band. Bent Holter, when he was playing in his band, he was studying for a master degree in microelectronics. And he was playing in the band, and he was playing at the live scene at the university, because they have their own rock scene. And their amplifiers broke. So they needed new amplifiers. And they didn't have enough money to purchase amplifiers. So he offered to build them amplifiers. This is how Hegel started in a very, very simple terms. And he built 6 of them, and 5 of them are still playing there. This number 6 is in our museum. But there he encountered a typical problem in amplification design. And this was that all amplifiers at the time, and almost all today, are built on a schematics by Toshiba that they made on how to make a solid-state, as transistor, amplifier. They made a drawing or a white paper of this in the early 70s. And all amplifiers are more or less built on this white paper from Toshiba. And this is the only little theory part. We will not dig very deep, but a little bit.
Yeah.
Because this is the whole reason why Hegel exists. In an amplifier, in this design, you use transistors. That was a big idea of the 60s and 70s. What this does, how it, in very simple terms, work. Hegel CD player is connected to one of the legs, the component. Look, like this. Black box with 3 legs. On the second leg, you have your transformer, power supply. Provide speakers. If in theory, if it receives 1 volt here, it will not do anything else, but it will open a little door and let maybe 10 times as much pass through here. The same current, but just 10 times more of it all the time through here. This is how a transistor, basically, amplification works. But also Toshiba knew that this transistor had one specific flaw or fault. 1 in, then it should be 10 out. So you should have a dot there. Then if you've got 2 in here, you should get 20 out. That's how it should work. But it doesn't. Transistors has a curve that looks like this. And that's why you have to make a correction to make the amplifier stable. So to do this, to fix this, in very simplified terms again, Toshiba invented something called
Feedback.
And if the signal goes through the amplifier, and then with a feedback correction loop, you take parts of the output and ships it back to the input. It's very, very simplified. This is feedback. And by doing this, you correct for the odd rising curve. But in the 80s and later in the 70s, people started detecting and measuring other problems with this design. Because, quite honestly, transistor amplifiers didn't sound too good in the 80s. And some of them still don't. Because of one special thing. Is that it does a bit more. So now we're back to music. If you play 1 kilohertz, a pure tone, ship it through your amplifier, then the transistor not only has this, but it creates something called distortion. And distortion are small copies of this sound you are about to reproduce on different frequencies. So all around this 1000 you get all these small extra sound. This is how intermodulation distortion looks. And you have harmonic distortion that is quite specific up here. Many extra small sounds. All these distortion elements is what is the characteristics of the transistor sound, because they are often in high frequencies and they're very far from the original. So when you want to hear, you're suddenly and that makes your ears go. It's unpleasant, it's unusable, and so on. Just to add this, if you read the technical paper, a tube amplifier will have much distortion, but that distortion is very, very close. It's a very high distortion, but it's very close to the original signal. So it's not appearing as harsh or unpleasant. Then back to this, and we're getting close to the end. When I amplify the signal, the amplifier creates these distortion elements, these copies. Then I take some of that signal and ship it back to the beginning. I ship also back the distortion, and it amplifies the distortion. So if the distortion was this big compared to the original signal in first place, suddenly it's amplified. So it's much, much more powerful. And then it really becomes irritating. And this was very, very bad. So what people or manufacturers started to do in the 90s is that they reduced this. But the problem then remained that the amplifier no longer actually worked optimally. It was not stable. Look at technical specification for amplifier. You will see distortion. In 1995, they say 0.7%. And in 2012, it says 0.007%, which is less. Less is good. Then you see in the old catalog, damping factor. In a very good amp, maybe 130. Today, it's not there. And damping factor describes the stability of the amplifier. And in practical terms, the amplifier's ability to start and stop a bass driver. And the reason it's taken away is not because it's become so good that it doesn't make any sense to have it there. It's because it's become so bad that you can't have it there. Because they take away this feedback to reduce distortion, but at the same time you take away the stability function of your amplifier, so you lose bass control. So today, actually, the damping factor or bass control of a class AB amplifier is AB is between 60 to 80. It's half of what it used to be. On a class D amplifier, digital, its effective damping factor is between 20 to 30. So you lose rhythm. It's not do 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 do, and the bass is because it cannot control the bass. And that brings us to the dilemma. You have to choose low distortion or high damping. You could not have both. And that basically is what irritated Bent Holter, our founder. And he wanted to use his master degree task or final paper about this, because the university he studied in Norway had purchased the first computer with software that could simulate electronic circuitry. And he used that to simulate this Toshiba drawing and testing various or ways to use it to find the optimal way. And this, quite simply, ended up in a patent that turned this around, where you made the same correction loop, but it always shipped the signal forward. And you were quite simply comparing the input with the output and doing a correction while always doing the same correction while always sending the signal forward. The technology is called adaptive feed-forward technology. I can make an advanced drawing, but not now because we don't have time. But this means that we can use the same feedback, but we never send any distortion back. It's always going forward. So distortion is still low, and we can make a lot of correction, so the damping factor goes higher. And we have a very stable amp. So for Hegel, this is more than 1,000. So it's more than 10 times the bass control of a normal Class A B amplifier. The final thing then is that it's, by comparing the input with output, it has something called threshold detector, where it measures differences between the input and the output. So it measures the level of these copies. And if it's more than a certain degree, it creates an equal signal in the opposite phase, reverse phase, to take it away. So you get very close to the original tone without it sounding harsh or having these transistor sound elements. And you get very, very good bass control in all our amplifiers with this patented technology called the sound engine. Does Hegel have a sound? It's something I've quite often asked. What sound does Hegel have? And I say that we are one of the few that do not tune a sound at all. We never tune our amplifiers to have a specific sound. Does a guitar sound warm or cold? It doesn't. It just sounds like a guitar. And the only way you can tune the sound in electronics, speakers is something completely different. But in electronics, the only way you can make something sound warmer is to add noise, background noise. If you add noise, it sounds warm. If you add distortion, there is something wrong, and it will sound cold or bright. So even when we build a completely new product, ground up, and we have designed this as good as we can to take away as much of the distortion as possible and lower the noise floor as low as possible, it always sounds in a specific way. It always sounds like a Hegel. So even though this one is completely different inside compared to this one, they still sound the same.